Question 29. Sketch the graph of the polynomial f of x equals 2 minus x outside of x plus 3 all times x plus 1 all squared. So we want to label the x and y-intercepts as well. So this is your typical graph of a polynomial. And there's a few things that we want to think about before we even graph this. And the first thing I want to think about is the degree. Because the degree of this polynomial will tell me the shape. So to think of the degree, just look at all your exponents and your variables on x. So this is an x, this is an x, and this is an x squared. So my degree is x to the 4. Okay? Now, that tells me I either have a W shape or an M shape. Now, to figure out what the leading coefficient is, that's the coefficient on the x to the 4. And to do that, that's quite simple. We just have a minus x times an x times your x squared. So if we were to expand this out, we'd get lots of terms. But our first term would be minus x times x squared. So our first term would be negative x to the 4. So what this implies about the shape of my graph is it's an upside down W, or as we would like to say, it's an M shape. Okay, so that is very useful information about this graph. The other thing that is quite interesting is we have a degree of 2 on one of our factors. So what that means is it's not going to cross the root at that point. It will actually, in fact, behave like a quadratic in the neighborhood of that very factor. So before we go any further, let's actually find the x-intercepts. So in order to find the x-intercepts, this is a nice, easy thing to do because everything's already factored. So, it's already in factored form, so we need to solve for each of our factors. So we got, I'll just write out this question. And of course, we know when we're finding x-intercepts, y equals 0, right? So that's what I substituted in for f of x. And lastly here, x plus 1 squared. So we got 2 minus x equals 0. Add x to both sides. Sometimes this tricks people and they get the wrong sign. So 2 is equal to x, so that's one x-intercept. These ones we're more used to seeing it in this form, right? So we got x equals minus 3. And then x equals minus 1. So those are our 3 x-intercepts. So just because it's a power of 4 doesn't mean we have 4. My y-intercept is also easy to find. And my y-intercept, we want an x equal to 0. So my equation becomes y equals, or f of x equals, so that's just going to be 2, right? Because 2 minus 0 is still 2, times 3, right? 0 plus 3 is 3. And 0 plus 1 squared, well, 1 squared is still 1. So 2 times 3 is 6. So my y-intercept is 6. So we have pretty good information onto what's on this graph now. It goes up to, well, it has a y-intercept of 6, and it has those x-intercepts. So let's put it on. If we want to think about scale for the x-axis, let's look at the intercepts we have. We have one at 2, one at negative 3, and one at negative 1. So I think a scale of 1 is fine. Negative 1, negative 2, negative 3. Hopefully they'll give you a better paper than this during your exam. But I'm trying my best to space it out evenly. 1, 2, 3. All right, so let's put on our intercepts. Our x-intercepts, we have one at 2. We have one at negative 3. And we have one at negative 1. Okay. Our y-intercept is 6. So I think I'm going to go up by 2's for this. So I'm going to go 2, 3, 2, 4, 6. And then negative 2, negative 4 is about all I could fit in here. And the other thing is we want to put on, so we have the y-intercept right at +6, so I'll put that on in blue as well. In blue at +6. So some other things you should do to get a nice accurate graph is we should probably substitute in some values. This is optional if we, you know, I believe the way this is marked, it's optional because we know it's going to, you know, we know how it's going to go. But we will do it nonetheless. Okay? So what's the first thing we'll substitute in? I would substitute in the -2. So let's just do -2 here. I'll just write it right here up top. So when x equals -2, we got a 4, right? Because 2 minus a minus -2. We got -2 plus 3 is 1. And then that's going to be a -1 squared, which is 1. So we got a 4 times 1 times 1, which is 4. So -2 goes up to a height of 4. Okay? What's the next one? The next one that I would recommend substituting in is 1. Okay? And if we substitute in the 1, let's see what we get. X equals 1. So we get 2 minus 1 is 1 times 1 plus 3 is 4, and 2 squared is 4. So 4 times 4 is 16. So here we see regrets about scale. So I think there's an important lesson here, is that if you're going to try to do an accurate graph, don't do your scale on your y until you're sure of some values. So let me just make sure, right? 4, yeah, that's definitely 16. So I can't show 16 accurately on this graph. What it means is the curve is still increasing through this point. So what do I do? Well, I get out my eraser and I change the scale. And this happens. It's nothing to get mad about, but it's a lesson that we should probably think about scale beforehand. So we want to go up to 16, so, you know, I'd probably do 5 now. 5, 10, 15, and then the 16 will fit nicely. Okay? You got to make sure you change the scale on your below as well. So -5, -10. Okay, looks like +3 is another value we should try here. Okay, so, and this may be too big to even talk about, but let's see. So that's a -1. 3 plus 3 is 6. And then that's 3 plus 1 is 4. 4 squared is 16. So it's really big, right? It's 96, -96. So I guess it's really small. But anyways, we won't be able to show that, but we want to show it steep. So the one thing that I would recommend, besides putting the y-intercept back in, so the y-intercept to 6 is now looking to be in an entirely different spot, but it's just because we changed the scale, right? And we want to put in the -2, 4, so just below. We want to put in 116, so just a little bit above the 15. And that should do it. Going back to the degree, so the ones with a degree of 1, the curve will pass through. The one with a degree of 2, right at the -1, it's not going to cut through. So here's how our curve goes. It passes through. It goes down. Now it doesn't cross because the degree on this factor is 2. So it goes back up. Now it's going to come back down and cross. And it goes relatively steep, because by the time it gets to the -3, it's down to 96. So I hope this graph helps you out. I probably should again calculate these values over here before I start drawing the scale. But at the same time, they may only be looking for, your x-intercepts and y-intercepts in your general shape. So that is it.